Hello everyone, I hope you all are doing very well. And in this session, we are going to see differences between CPU central processing unit versus GPU graphical processing unit versus TPU tensor flow processing unit. We are also going to cover that out of these three, which one is the right for your machine learning model, as well as we are going to cover each and every aspect of CPU, GPU, and TPU. And we are going to see their features and when to use CPU, when to use GPU, when to use TPU, and each and everything. So do watch this session till the end and subscribe the channel, like the video, and while watching the video, if you face any doubt, query, comments, then please feel free to comment in our comment box. We are going to reply them very shortly. So let's start. Basically, choosing between CPU, GPU, and TPU for your machine learning model depends on some key factors like what is the nature of your model on which you are working, the size of your data set, and the specific performance requirement. So let's start from CPU. Basically, CPU stands for Central Processing Unit. And if we explore some of the key features, then it have several cores, but low latency. It is specialized in serial processing. It is capable of executing a handful of operations at once. It have highest flops utilization for RNN, that is recurrent neural networks, and it support largest models thanks to the large memory capacity for that, and much more flexible and programmable for irregular computations. For example, small batches, non-maximal computations, right? So when to use, when we are having small data sets, we can go for the CPU, right? Because computational requirements are modest in that case. If we are having quick prototyping for experimentation during the early stage of model development, then we can go for CPU. For general purpose tasks, we can use CPU because it is versatile and we can handle the wide range of tasks, which is general purpose tasks. So it is ideal for general purpose computing, right? For the specific purpose, we can choose it for prototypes that require highest flexibility, for training simple models that do not require a long time, for training small models with small effective batch sizes. It is mostly written in C++, right? On custom TensorFlow operations. So for that purpose, we can utilize it. And model with limited input output or limited systems networking bandwidth, then also we can go for CPU. So there are some pros and cons as well. Basically, it is widely available in most computing devices. It is good for tasks which requires sequential processing. Sequential, right? Sequence by sequence. It is suitable for lightweight computation and small scale models. As well as we are having some cons as well, that it is limited for parallel processing capabilities compared to graphical processor unit and TensorFlow processing unit. It is slower for large scale deep learning models and datasets, and it is less efficient for heavy matrix computation, which is common in deep learning, right? So this is about CPU. Now, if we are starting with GPU, that is graphical processing unit, then we need to explore some features first. It have thousands of cores compared to the CPU, which is having very lesser. CPU also have cores, but not that much. It have thousands of cores. High throughput, the bandwidth utilization efficiency is high. Specialized for parallel processing. It is specialized for parallel processing. And it is capable of executing thousands of operations at once due to parallel processing capability. Now, when to use it? So whenever we are working on deep learning models, because CPU are not capable for deep learning models. So if we are working on deep learning models, then GPUs are excellent training and running deep learning models due to their massively parallel architecture. If we are having large data sets and GPUs are going to be useful for processing large data sets that require significant matrix operations, as well as for real-time inference. So GPUs can accelerate real-time inference tasks, making them suitable for deployment in production environments, right? So in that cases, we can utilize GPU. Further, we can add that if our model that is too difficult to change or sources that do not exist, in that case, we can go for GPU. Models with numerous custom TensorFlow operations that a GPU must support, in that case, we can go for GPU. If the model that are not available on cloud TPU, then we can utilize GPU. And if medium or large size model with bigger effective base size is there, then also we need to use GPU, right? So there are also some pros and cons with GPU. So pros which is associated with GPUs are like, it is highly parallel architecture which accelerates matrix computations. So due to matrix computations, it is very much efficient. It is significantly faster than CPUs for training deep neural networks, and it enables rapid experimentations and model optimization. Whereas some cons also associated with GPU, which are as follows: higher cost compared to CPUs. It requires specialized hardware and adequate cooling because it generates heat, and limited memory bandwidth for very large models are some of the cons, right? Now let's come to the TPU, that is TensorFlow Processing Unit. So let's explore some features first. It is special hardware for matrix processing. It have a very high latency compared to CPU, very high throughput, compute with extreme parallelism compared to CPU, and moderate if we compare it with GPU. And it have highly optimized for large batches and CNS, that is convolution neural networks, right? So when to use? When we are working on TensorFlow workloads, then TPUs are specifically designed to accelerate TensorFlow workloads because it makes them ideal for training and inference in TensorFlow based models. As well as if we are working on large scale models, then TPUs shine because when working with large scale models and data sets, due to their efficient matrix multiplication capabilities, as well as if we are having some cost effectiveness, then TPUs can offer significantly cost savings for large scale computations compared to graphical processor units. So these are the cases when we can go for TPUs. In addition, training models using mostly matrix computations, then also we can go for TPU. If training model without custom TensorFlow operations inside the main training loop, or training models that require weeks or months to complete, then also we need to choose TPU. As well as training use models with very large effective batch sizes. In all such cases, we need to utilize the TPU, that is TensorFlow Processing Unit, Tensor Processing Unit. So there are also some pros and cons associated. So pros are, it is optimized for tensor operations common in deep learning models. It is going to perform superior performance for training and inference tasks on large models. And it is cost effective if we compare it with the GPU for intensive machine learning workloads. Some cons are like limited support outside TensorFlow ecosystems. It requires access to cloud platforms, for example, Google Cloud for deployment. Learning curve for optimization and users compared to CPUs and GPUs. These are some of the cons, right? So choosing the right hardware is very important for your machine learning model for better optimization. So we need to consider model requirement first. We need to evaluate the computational demand of our machine learning model, which include the size of data set and complexity of operation. So based on this, we will choose which tool is right for us. Second is budget and cost, right? So first consider the model requirement. Second, we need to consider budget and cost. So we need to balance performance requirement with budget constraint as well, because in many institution organization, there is a budget constraint, as GPUs and TPUs can be more expensive rather than CPUs, right? So this is also the fact. And third one is cloud versus on premises. So we need to determine whether cloud-based solution, for example, Google Colab, AWS offering GPUs or TPUs are more suitable based on your needs and access to hardware. So based on these factors, we are going to choose which is the right hardware. And already we have discussed that what model we are working on and what is our specific requirement, that is going to decide which is the suitable tool for working on. So let's just briefly summarize again. If we talk about CPU, I'm just summarizing again. It has several cores, but GPUs thousands of cores. Low latency, it is high data throughput, high latency, here also high latency. In TPU, it is matrix based workload. It is serial processing, it is massive parallel computing, and here also we are having parallel computing. Right? Limited simultaneous operations, but here limited multitasking operations. Here we are suited for large base sizes operations. Large memory capacity, here memory is low, here complex neural network models are there, and high data throughput. These are some of the keywords that is suitable with GPU, CPU, and TPU. So if matrix based model, TPU. If high latency, TPU. Data throughput high, TPU. Large base size, TPU. Complex neural network model, TPU. Massive parallel modeling, GPU. Limited multitasking, GPU. Low memory, GPU. Thousands of core, GPU. High data throughput, GPU. High capacity, CPU. Large memory capacity, CPU. Several core, CPU. Low latency, CPU. Serial processing, CPU. General purpose task, CPU. So I hope the differences between GPU, CPU, and TPUs are clear. And based on this video, this is going to definitely add some points while choosing the right tool for your machine learning tools. Do stay tuned for more such videos and lectures. Subscribe and definitely please share it among your friends and colleagues as well. Have a nice day, guys. Jai Hind, Jai Bharat.